The next section will show you how to configure SIP calls voice over IP codecs from TelcoBridges T-Media Gateway web portal. This configuration flow diagram illustrates where we are in the configuration process. Now that we have configured SIP and SIP naps, the next step is to define profiles to describe per-call system behaviors and configurations, such as the voice over IP codecs. Let's first quickly review why voice over IP codecs are used to transport the media. The first step is called sampling quantization. It converts analog voice signal into digital signal. Each sample's value is expressed by a binary code of 16 bits. A codec stands for coder and decoder, converts the 16 bits PCM codes into a compressed digital form for transmission over IP. The compression saves bandwidth. Another way to save bandwidth is by using silence suppression, by not sending any packets when there's no voice. Here, the 16-bit samples are compressed and coded to 8-bit codes with either G711 EULA or ALA encoding scheme. After the encoding of the digital signal, the bit of stream is encapsulated in packets and sent in RTP packets over either UDP or TCP. The codec information is carried by SIP signaling using the Session Description Protocol defined in RFC 4566. The Session Description Protocol, or SDP, is a format for describing the media. It is intended for describing the media session profile such as connection and media information. For simplicity, we will focus on some parameters of the C, M, and A lines. The connection line defines the connection IP used for receiving and sending RTP. The media line defines the transport port and the codec payload types supported. And the media attribute lines define supplementary information for each codecs. This table lists the VoIP codecs supported by the T-Media and their respective RTP payload type numbers. For more details about TelcoBridges supported codecs, see the reference link in this course from the e-learning platform. Some payload type numbers are defined by specification. For example, 0 is used by G.711 EULA. However, some codecs does not have predefined payload type numbers and are therefore negotiated dynamically, meaning that the application can attribute any payload number between 96 and 127. For example, RFC 4733, also known as RFC 2833, defines a method to carry telephony events such as DTMF or tones out of band in RTP packets. This codec does not have predefined payload type and must be specified with an attribute line in the SDP, often defined as payload type number 101. Finally, just a quick note on comfort noise. RFC 3389 defines a method to transport comfort noise in RTP packets for codecs which does not support native silence suppression. User Agents uses a mechanism called Offer Answer to negotiate the media codec capabilities by carrying the SDP information in the body part of SIP messages. Let's look at an example. UA.A sends an SDP offer in the invite SIP request to S.B2BUA. It specifies its IP or domain and port to receive RTP and the supported list of codec payload types. B2BUA routes the call to UA.B SIP NAP and modifies the SDP according to its NAP associated profile. Here, G.711 profile. It removes the payload type PT18 or G729 and sends an SDP offer to UA.B. It also specifies the receive IP domain s.b2bua.com and port 20000. UA.B sends an SDP answer in the 200 OK SIP response, providing its receive information ua.b.com at port 8005 and specifying codec PT0 or G711 EULA as the only codec supported by this phone. The G.711 EULA RTP stream is then established between s.b2bua.com port 20000 and UA.B.com port 8005. B2B UA modified the SDP, keeping only the common codecs between the received codecs from UA.A and its own UA.A NAP profile, here G.729 profile. It sends an SDP answer providing its receive information and supported codec PT18 or G.729AB. The G.729AB RTP stream is then established between UA.A.com port 9000 and S.B2BUA.com port 25000. In this example, the T-media transcodes the media from G729AB to G711 EULA between UA.A and UA.B user agents. So as we saw in the previous call flow, T-media uses profiles to define the codecs to be used for the SIP offer answer negotiation. In the web portal, from the profile left menu, you get the list of profiles defined in the system. If you edit a profile or create a new profile, you will find the SDP section which defines the codecs with SDP description. The default profiles SDP defines the media line with G.711 EULA, G.711 ALA, G.723.1, G.729AB, telephony events, and comfort noise. Note that the list of payload type numbers are given in order of priority. Profiles are associated with NAPs or routes. The SIP messages for all calls are exchanged in a single connectionless UDP communication between the T-media and the remote SIP destination. Here the T-media would use the port 5060 and the IP 192.168.101.160 to receive the SIP messages. Each connected calls result in an RTP media stream and a real-time protocol control or RTCP data stream between the T-media and the remote SIP destination. RTCP is out of scope for this base course. For more information, please refer to the TelcoBridges wiki documentation. Even if RTCP is not configured from the profile, the RTCP ports are always reserved by the T-media. For example, 1000 SIP calls would take a range of 2000 UDP ports. In the next hands-on activity, you will learn how to configure the VoIP profile from the T-media Gateway web portal.